something like that.
We're gonna go from LA to Dallas.
That's pretty far.
San Jose.
That's not that far.
Okay, let's say we go.
I have points.
These are actually directed, by the way. So let's say LA to Denver.
Okay. So you will go from LA to San
No,
Jose.
no, we need one with two different paths. So
Have one go from San Jose straight to Denver. Oh, San
how
Francisco
about San
straight
Francisco
to Denver.
So
Yeah.
either we could go through LA
Or go
or
straight
we go
from.
through San Jose. Okay, so basically what happens is we have to make our adjacency list. So we'll just have an array here. 0, 1, there's 5, right? 2, 3, 2, 3, 4. So 0 is going to represent San Francisco. So it's going to be, let's just put the city names in there. So let's say San Jose, Los Angeles, and then Dallas,
Why is not LA the first
and
one?
Denver. What?
Why is not LA the first one?
It doesn't, we don't
matter?
We don't know. We're just,
Okay.
this is just the
Maybe
data structure.
we put it into a hash function.
Yeah, I mean, we don't know where we're, and that's
Oh,
for the
okay,
user
okay.
to decide. There's just some array set up. And then we have the adjacency list. So that's a one, a 1 and a 2. So 1 and 2. So those are the cities we can reach. And then San Jose just has a 3, right? Because I can only go there. And then LA, I can go basically only to San Jose, so
Or
that's a
San Francisco.
1, right? LA, I can only go there. And Dallas, I can only go to Denver, so that's a 4. In Denver, I can't go anywhere, so that's empty. Just put nothing there. Is that right? So 2 from San Francisco, then everything else has 1, right?
Yeah.
LA to San Jose is the 1, and then San Francisco also to San Jose, so that has a 1. Okay, so let's suppose that's right. Okay, now, so I want to go from San Francisco, was it San Francisco to Denver?
LA to Denver.
Oh, you want to do LA? Okay. Although there's only one path. Okay, so
Okay,
LA
that's San
to
Francisco.
Denver. Okay,
San Francisco.
So San Francisco, okay. So here's what we do. We have this queue. We're going to have another array over here somewhere. So these are also cities. This is going to be called predecessor. Predecessor.
This is essentially Dijkstra's algorithm.
Well, yeah, except Dijkstra's doesn't. The way we shot, we didn't keep track of the path. So that's what we have. That's what this is going to do. The other thing that's different about Dijkstra's algorithm is Dijkstra's algorithm. You ended up updating distances sometimes because you found a shorter distance. That doesn't happen here because once you get to the city, once you see the city, that's automatically the shortest distance. The thing about Dijkstra's algorithm is like you could have something like 1, 5, right? And then you have no, it's 1, 2, and then you have 4, right?
Right.
Now you might. So you start here, right? And then you add these 2 vertices, right? So the distance to this one is 1, the distance to this one is 4. Then you add this one, and you find out, oh, I get from here to here in another 2, so then you update the distance to this. But see, that doesn't happen with this, with where we're
Because they're
only,
all ones,
because everything's
essentially.
1. So basically, as soon as you get there, that was the shortest number of steps to get there. So it's not like you found there's some shorter way to get there with more steps because each step counts
As one.
Right.
as 1, right?
So
it
less
makes it
cities are
easier.
better.
So basically, this makes it easier. But we still have to keep track of how we got there. So here's what we do. We have a queue. So we have a queue somewhere. Draw a queue. Let's just make a queue. Let's say that's the queue. So this is the front. This is the back. Okay, so first of all, since we're going from SF, the 0 is on the queue. And then, okay, here's what we do. We pop
0.
the Q, and we push on the adjacent vertices. So that's going to be a 1 and a 2. And we have to put how we got there. So that's going to be 0 and 0. Meaning, the way we got to vertex 1 was through vertex 0. And the way we got to vertex 2 was through vertex 0. So those are called the predecessors. Because later we're going to have to retrace our path. This is the only way we can know what the path was. Okay, so that's done. Now, and these aren't going to change. Basically, that's their predecessors. So that's how you got to those two. Now we're going to pop the first one, the 1, and push a 3 on there. And the 3 we got to from 1. So that was the Dallas. So that's done. Now we're going to pop the 2. And the 2 is LA, and that goes to 1. But we've already visited. See, that's the thing. If you've already visited the vertex, you don't
Want to go back?
push it onto the Q. And we know we've visited LA,
Because of the
actually, because we can just look at
the
this thing. So we just look at LA, which is 2 and L. It's filled in with something. I guess these are -1s or something. I guess the other ones have to have some dummy value. Right? So these have some like
-1
-1 or something like that. I mean, we haven't visited it yet. Okay, so have we gotten to Denver yet? No. So we pop the 3, and then we push the 4 on, because that's connected with 4, and 4's predecessor was 3, and that's the vertex we're looking for. So now we have to find the path. So we start at 4. 4 came from 3. 3 came from 1. And 1 came from 0. So that's 0, 1, 3, 4. So that's our path. That's it.
Because when you already visited it, that's the shortest path. Because
Yeah,
if you see it again,
exactly.
that's not the shortest path.
And to reconstruct the path, you start at the destination vertex, look at how you got there, which is that, then go to that index, look at how you got there, etc., and that takes you back to the start. Very cool. But you need this. You can't do without this, because you're not recording your path. You're just, if you didn't care about the path, you wouldn't need this.
Right.
And also you want to know maybe the distance as well. So this way you don't really have to keep track of the distance as you're doing it. You just count that length.
Denver wasn't 3. Denver was no. Remember? That's
No,
what is.
But you got to Denver from 3.
No, I
got to Denver from Dallas.
What do you mean Denver wasn't 3?
The 3 is the...
The 3 represent Dallas or Denver?
Dallas.
These are the same thing. So the 3 is Dallas, the 4 is Denver.
Oh, okay. So the 3
2 is
inside.
LA.
So 3 inside. This means that you get to 4 by using Dallas,
Yeah.
right? Okay.
So to get to this location, we came through
From
this
3,
one.
number 3.
Right.
Okay. Oh, now it makes sense.
Yeah, and that never had anything in there because it never came from anywhere. That was our starting.
That was 0.